Namaskar students. So in this lecture we are going to discuss about the unit impulse response of first order control system. Okay, so in previous lecture we have already discussed about unit ramp and unit step response. In that case we are going to study unit impulse response. So we know that the transfer function of first order control system can be written as 1 divided by as t plus 1, where you can see the power of s is 1, that is why we can say it is first order control system, and t is the time constant of the system. Now for unit impulse response, whenever we are giving unit impulse signal as an input to any kind of your particular mathematical modeling of any kind of system, in that case value of r of s is 1, and if you put the value of r of s into this equation, you can write your c of s can be 1 divided by as t plus 1. Okay, now if you take the t common, in that case your equation can be rewritten as s plus 1 divided by t, and if you just take the inverse Laplace, the c of s will be c of t, and the 1 upon t is constant, and the Laplace inverse of this particular term is e raised to minus t upon capital T. So this equation is nothing but your unit impulse response of first order control system. Here the t is capital T is time constant. So if you just draw this response, so this is your x axis, that is t, your output c of t. Okay, we are giving a unit impulse signal to this particular system, that is 1 upon s t plus 1. So if you just put t is equal to 0 at time t is equal to 0, we want to find the value of your output. So if you put t is equal to 0, and this term will be 1, because e raised to 0 will be 1. In that case the value will be, let's say this is 1 upon t. Okay, so c of t will be 1 upon t only. And for time t is equal to infinite, if you find c of t, so e raised to minus infinite, it will be 0. 1 upon t multiplied by 0 will be 0. Same way you can find for t is equal to 1 second, 2 second, 3 second, and so on. So in that case you will get this is kind of response. Okay, so this is nothing but the unit impulse response of your first order control system. So as your value of t, that is time constant, is changing, your system improves. Okay, behavior of the system improves. Now let us try to solve one example, that is a system that is having a transfer function is c of s by I of s is equal to 20 divided by s plus 10, and we are interested to determine the unit impulse, unit step, and unit ramp response with the assumption that the zero initial condition. So let us first start with unit impulse response. Okay, so for unit impulse response, the value of r of s is 1. So if you put this value in this equation, your c of s will be 20 divided by s plus 10. Okay, so if you just find the inverse Laplace of this equation, in that case it will be 20, and the inverse Laplace of 1 divided by s plus 10 is same as 1 divided by s plus a, and that is nothing but e raised to minus 80. So here you can say e raised to minus 10t. Okay, this will be your answer or response of this particular system as far as unit impulse response is concerned. Same way, if you want to find unit step response, in that case you have to put the value of r of s is equal to 1 divided by s. If you put this value, this equation can be simplified as 20 divided by s plus 10 multiplied by 1 upon s. Now if you take the partial fraction a divided by s plus b by s plus 10, and if you find the value of a and b, okay, we have already discussed how to find the value of a and b using the partial fraction. If you do so, you will have a is equal to 2 and b is equal to minus 2. Okay, this will be your final output, and to find the time response you have to take the inverse Laplace, and if you do so, the value will be c of t, your 2 is constant, and 1 upon s, the Laplace inverse will be 1 only. Same way 2 is constant and Laplace inverse of s plus 10 will be e raised to minus 10t. So this will be your time response for unit step signal. Same way you can find for unit ramp signal. In that case you have to put the value of r of s is equal to 1 divided by s square, and if you put the value of r of s in this equation you will get c of s is equal to 20 divided by s plus 10 multiply by 1 divided by s square. Okay, same way you can find a divided by s square, b by s and c by s plus 10. If you do the partial fraction you can have the value of a, b and c. Okay, I am not going to find right now, so if you do so you will get such kind of values 0.2 s plus 10. Now you can take inverse Laplace, and if you take it, the c of s will be c of t, 2 1 upon s square will be t, 0.2 1 upon s will be 1 only, plus 0.2 is constant and Laplace inverse of this term will be e raised to minus 10t. So these three are the unit impulse, unit step and unit ramp response of first order control system. Okay, so easily you can find the value of your c of t in case of all the three responses. Okay, thank you so much.